Let me see. Good evening, everyone. Welcome to Water Wednesdays. We are so glad you could join us. My name is Rolando Gonzalez, and I'm a community affairs representative for EBMUD. Water Wednesdays is EBMUD's monthly webinar series where we talk about water, wastewater, and other topics of interest meant to educate customers and residents in the EBMUD service area. Tonight's webinar is being recorded, and by joining us, you are agreeing to be part of that recording. We will be posting this video of recording on EBMUD's YouTube channel by the end of this week, hopefully. Tonight's webinar topic is firefight, fuel management in the age of climate change, which has become a very important topic, not only across California, but also the West. So this is a very important topic, and we're glad you could join us. We have two great speakers tonight. We'll be first hear from Mr. Scott Hill, who is EBMUD's manager for our watershed and recreation. And afterwards, we will hear from the East Bay Regional Park District Assistant Fire Chief, Mr. Kari Hele, who will be talking about vegetation management in their parks, which many of them adjoin our own EBMUD watershed. Just a little bit of logistical issues. You can always put your questions in the Q&A. You don't have to wait until the end. You can actually just put them in there, and at the end, we will put these questions towards the presenter. We have a lot of information to cover tonight, so if you have any questions that did not get answered, or if you think of something later on, you can always send us an email at community@eastbaymud.com. Okay, and having said that, let me see if I can get this thing to, let me get this on presentation. So tonight's presenters are Mr. Scott Hill and Mr. Kari Hele, and the agenda, as I said before, is program objectives, strategic planning, implementation, and monitoring. I will be talking very briefly on fire hydrants and the roles in neighborhood firefighting, and then we'll close with the East Bay Regional Park District Chief Hele. Thank you very much, and now take it away, Scott.
All righty. Thank you very much, Rolando. Welcome, everybody. Thanks for joining us. As Rolando mentioned, we have quite a few slides to go through tonight, so I'm going to have to talk fast and stay on track. Not spend too much on each slide, but hopefully during the question and answer session, if there's anything you'd like me to elaborate on or address, you'll have plenty of time to bring it up then. Next slide, please. This first slide is just an overview of East Bay Mud, really the McCollum watershed, as well as the local watershed. And you can see, looking at the slide in the upper right-hand corner where it shows the McCollum River watershed, that's the source for the majority of the water that comes to the East Bay through the three aqueducts. Approximately 95% of our water supply comes from the McCollum. The local watershed contributes only about 5%. And so we're really fortunate that we have such a high quality source for our supply on McCollum. Most of that is all snow melt. And that watershed is very, it's predominantly granite in terms of the soil composition. So it's not really soluble. The water that comes into the Pardee Reservoir at that location is very, very clean to begin with. Into the aqueduct and down to the Bay Area, 90 miles, gravity flow, which I always am amazed that the engineers, the forefathers of East Bay Mud, had the foresight to develop a system that could deliver water 90 miles to the East Bay. It's been a very reliable system for almost 100 years now. But anyway, so it delivers us really high quality water. We store it in 5 terminal storage reservoirs in the East Bay. Those reservoirs and surrounding watersheds is what I'm responsible for managing. And particularly, we're going to be talking about the fire management around those reservoirs tonight. Next slide, please. This slide is taken from up off of Wildcat Canyon, close to Inspiration Point, one of East Bay Regional Park District's parks, Tilden Park, and it's looking to the northeast. That's Briones Reservoir that you see, and then the forested area on the backside of the reservoir there is a Monterey pine forest. It's the largest Monterey pine forest we have in the watershed, the largest non-native tree species and forest that we have on the watershed, and it covers approximately 300 acres on the east side of San Pablo Reservoir. Those trees were planted in the mid to late 30s. The prevailing wisdom at the time was that Monterey pine were a very good species to use for slope stabilization. And it seemed like a logical fit to plant those along the shoreline of the reservoir to help hold the hillsides in place, provide some biofiltration. And so they were, like I said, over about a 5 or 6 year period, they were planted approximately 30,000 trees. Next slide, please. In 1996, East Bay MUD developed a watershed master plan that was approved by our board of directors. It was a 3-year process with a lot of community involvement. There were 30 community use groups that participated throughout the process, covering a full range of different land uses, including recreation as well as all natural resource management, and kind of everything in between. That plan was adopted, and it established goals for water quality and biodiversity. It also recognized the need to incorporate fire and fuels management into the plan, and that it needed to be an integral part of the plan, and that it couldn't stand alone, and that effective resource management, watershed management in particular, would require full integration for fire and fuels management. One, for it to be sustainable moving forward, but also so to ensure that that we maintained watershed function, the highest watershed function possible. Fire and fuels management needed to be integrated into the other management programs, and also the goal was to create a resilient watershed landscape. Recognizing that fire was an integral part of resource management, and that really there's nothing you can do to exclude fire. And so the goal was to, recognizing there would be fire on the watershed, to manage the watershed in such a way that when fire did occur, that it wasn't catastrophic. And both in terms of its effect on the resources, on our water, as well as to the surrounding neighbors. And that it provided adequate, we provided adequate protection for persons and property. Next slide, please. So there was a risk assessment done. There was fire modeling done throughout the watershed to identify hazards and begin to identify treatment methodologies and appropriate levels of treatment, and that varied by area throughout the watershed. The thought was that the interior of the watershed would be managed more like a refugia, and you could have more fuel in the interiors of the watershed, versus the exterior, the interface areas would be managed more aggressively to reduce fuel loading and ensure protection from the adjacent neighborhoods. And the overarching goal was to develop a system throughout the watershed, a strategic approach that basically created a box around the entire watershed, and then with pre-containment lines and management, fuel management zones, and so on and so forth, basically utilizing the topography of the watershed, the fuel types on the watershed, and the existing natural features of the watershed to facilitate containment of a fire in the event of a wildfire, and to have pre-deployment plans, recognizing that by utilizing these features, you could deploy suppression resources in such a manner to maximize their efficacy for containing a fire. And in doing so, you also minimize the impacts to protected species, to sensitive vegetation, and just the typical impacts that are associated with wildland fire suppression that sometimes can be deleterious to water quality. Next slide, please. This is just a shot showing some fuel management adjacent to the Sleepy Hollow School in Orinda. You can see the grassland has been grazed down, reducing the overall fuel load of the grassland. That's accomplished at this location with goat grazing. And that's to provide a buffer around the school. You can also see how the effects of the grazing on the downside of the field there, how the fuel bed is maintained in a mosaic pattern on the downhill side. There's not a lot of brush infill there. And then that also borders the residential area there in North Orinda. Next slide, please. This is another shot looking at, this is San Pablo Reservoir looking to the north. And it's just a photo showing some livestock, some cattle grazing. We rely heavily on grazing to manage the fuel load in the annual grasslands. The annual grassland is the predominant vegetation type we have on the watershed, on the 29,000 acres around the 5 reservoirs. So cattle play a big role in managing the fuel load around those on the watershed land. And like I said, these are predominantly annual grasslands. So they come back every year. Fuel treatment, is necessary on an annual basis. And we do a number of different types of treatment throughout what we call the fuel management unit to get fuel loads to that acceptable level that I mentioned early on as part of the strategic plan. We don't just rely on one type of fuel treatment. We usually use 5 or 6 types of treatment methods in each fuel management unit. There are 33 fuel management units on the watershed, starting from the north watershed in Pinole and working all the way south to Castro Valley. The watershed is broken down into those 33 management units. Next slide, please. So program objectives. I talked about the objectives a little bit to really, reduce the fuel load to an acceptable level to prevent a catastrophic fire that would be really damaging to the resources and potentially to water quality. And then, of course, to prevent a fire that originates on the watershed from leaving the watershed. So interdisciplinary coordination, that gets back to the master plan, and managing the watershed, we're really managing for watershed function. That's what's paramount, that we manage the watershed in such a way that we can maintain the quality of water that we receive from the Sierras into these reservoirs. There's a lot of other potential impacts in the urban area versus the rural area when it comes to water quality. There are roads all around throughout the watersheds. There's pollution associated with traffic on those roads. Then there's also a lot of developed area around the watershed, residential development. There's golf courses. There's a whole array of land uses that could potentially pollute the drinking water. And so we're always trying to maintain the highest level of watershed function, because that area, the watershed around the reservoir, provides for biofiltration and really helps to protect water quality. So the interdisciplinary, we're managing forestry, we're managing rangelands, we have recreation assets, and we have other land uses through entitlements. We have PG&E with right-of-ways for transmission and distribution towers across our watershed, and then we have other interests as well. But with the goal of maintaining maximum watershed function, as opposed to just singularly focusing on one management objectives, like fuel management, for example, and the pines that we saw earlier on the east side of San Pablo Reservoir. They're over the last 3 years, they've been experiencing a significant increase in decline based on the weather, and kind of a combination of some other factors, but really brought to a head with the climate change that we've been experiencing. And so mortality has increased fourfold over there from what it had historically been. And there are a lot of dead standing trees there, and there's a lot of concern about the fire hazard that the additional trees pose, additional dead trees. But because of these other co-goals, the water quality and the other resource goals that exist for biodiversity and sensitive resource management, we're resistant. We do not want to just remove all those trees at one time. That could have an adverse impact on the reservoir in terms of potential sedimentation into the reservoir during storm events. There's also sensitive species that live over there and use those trees. Even dead trees provide habitat for a whole array of species. And so there's a balance needs to be struck to protect the public, to protect the surrounding neighborhoods, to protect the resources that are there, like I said, from a high intensity, uncontrolled wildfire. But that doesn't necessarily mean that the best approach is to go and clear cut all those trees. We don't believe that is. We've systematically been removing those trees and trying to reduce the fire load and implementing other mitigation measures over there to provide for an appropriate level of protection while we're in the process of removing those trees. So that's just an example of managing several goals at one time. Next slide, please. So the strategic approach really enables us to minimize the impact to the other resources on the watershed, and there again to help maintain that watershed function that I was talking about earlier, as opposed to just focusing on one sort of discipline and managing one resource in isolation. We really have a holistic approach, and that's what's needed to maintain watershed function. Once you start to focus or over-focus on any one particular area, things tend to become imbalanced, and that's where trouble can begin. I mean, there can be a lot of unintended consequences when things get out of equilibrium. And so we're always trying to kind of maintain this environmental equilibrium. And oftentimes that may be frustrating for people because they wonder why it takes so long. But nature typically does take a long time. I mean, trees die all the time. They fall on the ground, they decompose, but that takes time. But that's a very important process in terms of forest health, and in terms of watershed function. So we want to maintain that function as much as we can, while still addressing the risk that comes with the accelerated die-off that we're seeing in this case, of the pines. Okay, fire management units, I talked about that a little bit, and we can go to the next slide. As I Thank you. As I mentioned, we have the watershed broken down into 33 fire management units, starting from the North Watershed in Pinole and going south to Castro Valley. And really, what defines these units is the watershed basin or the watershed sub-basin. They're roughly 100 acres apiece, or 1,000 acres apiece. But the basin and the sub-basin are really, as a topographical or geographical designation. But the watershed, if you imagine the watershed as just being a bowl, and down in the center of the bowl is the reservoir. So up along the rim of the bowl is the rim of the watershed. And those are ridge lines. And ridge lines are strategic places for fire containment. The ridge lines are ideal spot for aerial retardant drops, for air attack. Air attack is very important in wildland fire containment. And so all these FMUs, these fire management units, are a bowl. And then those ridge tops are maintained in such a way to maximize their holding capacity for wildland fire. And then off those bowls, we have the subbasins in there, and those are basically boxes within the box to help contain the spread of a wildfire. And when we manage fuel, we just don't focus on the interface. I know a lot of times the public will call and they'll say, hey, I've got to remove this tree in my backyard, and right next to me on your property, you have trees and you're not removing them. Well, sometimes we do and sometimes we don't. But the bigger picture and the thing to understand is, in a residential setting, even in a wildland interface residential setting, there an intermix in particular where there's residents interspersed with a lot of wildland vegetation. The opportunity to really treat that vegetation is limited because of the property ownership. They're smaller parcels and you can only do so much. And then also in that sort of environment, the houses contribute a significant fuel load to the fuel complex. If you're really looking at the whole picture, the houses are part of it. You can't exclude them. They're a significant part of the flammable material within that fuel complex. We're on the watershed and we're talking about fire management units that are roughly 1,000 acres apiece. We have a much bigger, canvas to work with. And so while it may not look like we're doing anything right next to your house or right on the property line, we may be doing something throughout that 1,000 acres to minimize the fire behavior and the intensity and how hard that fire is going to bump up against the property line. So oftentimes I know homeowners are frustrated and think East Bay MUD's not doing anything. When I think really the reality of it is what probably the majority of what we're doing is really not visible to the public because it's further away. Next slide, please. This is just moving through the units, moving from north to south. The two blue reservoirs in the picture are Upper San Leandro, more in the middle, and then Chabot, Lake Chabot on the lower bottom half. And that's down in the Castro Valley area. And you can see kind of the topography on that Upper San Leandro Reservoir watershed, looking at the relief map. I mean, that's really some steep, tough country. But there again, our strategy is to use that topography to best advantage wildland suppression resources to contain a fire. It doesn't make sense to apply those resources in the steepest, most treacherous, most challenging conditions. It's unduly hard on firefighters. The chances of success, containment are nominal. Where you have the luxury of being able to wait till the fire moves to the lee side of the ridge, to a situation where containment is going to be much easier. It's much less risk for the firefighters. It's safer. You may have a little more black area, but it's safer for everybody involved. Next slide, please. So those fuel breaks, those boxes, they're linked to the naturally resistant fire features within that watershed, whether that's a drainage, whether it's a reservoir, whether it's a more fire resistant fuel model. All those features, whether it's a rock outcropping, they need to be factored in to suppression action. If a fire is burning in a fuel model that's really hot, produces really high flame lengths, little chance of stopping it, that's not the place to try and make containment. If it's going to burn out of that and transition into a flatter slope or no slope, a lower fuel hazard, maybe from brush to grassland, or maybe it's going to bump up against a fuel treatment area. But all those treatment zones are connected to other fire resistant features. There again, with the thought being maximize the opportunity for containment. Okay, if we go back to that slide, that just below that are just some of the treatment methods that we use. We use cattle, like I mentioned, horses, goat grazing, horse logging, and so on and so forth. And we can talk about those later if you have questions. I think I'm using up a lot of time, and I want to save some for Chief Hele. This is another picture of an interface area that's up off of Wildcat Canyon Road, bordering on Orinda. That's the stables there. You can see that area has all been grazed off. You can see how it follows the fence line from the top of the photograph, where there's a little clump of trees. You can see the fence line coming down to the next clump of trees. Everything to the right has been grazed down. That's been grazed with goats and lives and cattle to reduce the fuel load. So it bumps up against that interface area a little more gently than it would if it was ungrazed. Next slide, please. Same area from a different angle, but this is also showing the grassland, and then the transition into that brush field that's adjacent to Lomas Cantatas. But you can see that brush field is grazed by goats to maintain that spatial separation that you see there. Typically that would be solid brush, more like the brush field you see in the foreground. But we want to take some of the fuel out of it. So when it transitions from that grassland into that brush field and then up to the road, that we've taken enough heat out of it and enough fire out of it that we could hold it at the road. That's okay. Go to the next slide, please. This is just a picture of a horse logging operation. This was up on Grizzly Peak as well. That's just using a draft horse to skid a eucalyptus log. For several years, we used draft horses exclusively up there. They are very, very low impact. They don't require any roads. Very little post-project rehabilitation required. Very, very easy on the land. Next slide, please. This is a disc line along a county road out in, this is Bear Creek Road. That's a kind of a typical roadside treatment, with the objective being to try and catch an ignition from the roadside. It'll come through the little grassland, the grass margin there. And then the disc line, it's an effective technique for catching or slowing down a roadside ignition and giving first responders an opportunity to get on scene. Next slide, please. The Fire Atlas, that's another byproduct that we created of the master plan and the fire management plan. And it shows all 33 fire management units with topographical relief and all the features, all the all the natural features as well, but also it was built off a digital elevation model. And so it really gives an intuitive, when you look at the maps, you get a real intuitive sense of what you're looking at, just because it's essentially a 3D rendering. Next slide, please. Okay, we need to wrap it up. Okay, I'm good. I don't know how many more slides we have, but if we need to wrap it up now, that's fine. I can take questions later. Yeah, these are just examples of the FMU. Yeah, those are Atlas pages. There again, Atlas. The Atlas shows the modeling that was done, fire severity under normal fire season, which is typical weather that we get this time of year, and then late season is 95th percentile. So those are like Diablo wind conditions on the right. It just shows you, it's a comparison. So you have an idea just by looking at the map of what kind of fire you could experience on the ground at that location under normal versus 95th percentile, high fire severity weather. Yeah, San Pablo. More examples of out of the Atlas, just contrasting the different conditions. All the work we do is monitored by biologists and any other disciplines that are needed, but always a biologist. And then post-project, always following up. I mean, everything you do with resource management needs to be adaptive. You need to monitor closely everything you do, and always be watching for unintended consequences and be ready to make adjustments as needed. Next slide. That's the pines. It's showing some of the mortality. And it's just, like I said, it's increased fourfold over the last 3 years. We've been working over there for 20 years and keeping up with it until 3 years ago. And then climate change and just the condition of the trees, they're all old. I mentioned they were planted in the 30s, so they're at the end of their life. There's a lot of pests over there, predominantly bark beetle. And so it was kind of the perfect storm. Everything aligned, and the drought, they're really drought stressed. So the mortality just really jumped 3 years ago. Trees. Yeah, typically we don't plant a lot of trees because we don't remove a lot of live trees. Most, in terms of fuel management and forest management, we don't remove live healthy trees. We let them live out their life. In the event, the trees that we're removing on the south of the San Pablo or northeast of San Pablo Reservoir are dead. And even then, we're trying to leave them standing as long as we can and reduce the fire risk to an acceptable level, because they do, as I mentioned earlier, provide an important environmental function. And the reforestation effort on that project for the last 20 years has been release the native trees that are growing in the area through the selective removal of the pines. And that's been working really well. The natives the oaks are coming in very well. We have really good age class distribution. So we have young trees all the way up to trees now that are 20 years old. And we haven't planted any trees over there. The trees that are growing on site throughout the watershed in areas where tree removal takes place, they're the best trees. They're indigenous. The survivability of those trees is much, much higher than trees that are imported. Okay, let's close it up then, Rolando. Yeah. I'll turn it over to my colleague Rolando to talk about fire hydrants.
All right, thank you, Scott. That was a lot to unpack, a lot of good information. I'm just going to give you a brief history on fire hydrants and their role in firefighting. Fire hydrants have been around for almost 200 years. They were first invented in 1801 in Philadelphia, Pennsylvania, and Frederick Graff, who is not the original inventor, but he is credited with the first patent, so he got all the glory. So they've been around for more than 200 years. EBMUD installs and maintains approximately 31,000 fire hydrants throughout Alameda and Contra Costa counties. And these fire hydrants are very simple devices that are unique to water systems and agencies, because even though we install and maintain them, they are operated by other agencies such as your local fire department. Just to give you some brief statistics, as I said before, EBMUD has about 31,000 fire hydrants in the service area. We inspect about 800 hydrants annually. 400 to 500 are repaired every year based on issues that are detected or reported, such as leaks or the occasional car that just sort of plows into one of them. And we need to do emergency repairs, but we do a lot of maintenance on these devices. These things are very robust mechanical devices. They are prone, they're very sturdy, they aren't prone to operational failures, but over time they tend to leak. And the average lifespan of a fire hydrant is about 20 years. EBMUD worked with fire departments to put together to ensure that these fire hydrants are installed in the proper locations, and they operate and are accessible in case of our neighborhood fire. And any issues related to fire hydrants accessibility should be related to the applicable local fire department in your town or city. Lastly, we want to say, because these devices have the name of the water agencies where they are often associated with these dangerous scenarios, these wildfires. But, because they carry the water agency's logo or name. And these hydrants, the flow, I won't go into detail, but the color of them means different flows. So if you see one color, red means a certain flow, gallons per minute. Another yellow could mean something different. It depends, but these standards are set in accordance with the California Fire Code. And the primary of hydrants is to support fighting neighborhood fires, not wildfires. So we just wanted to get that brief information to you. And now, without further ado, I would like to turn this over to the Chief Carrie Haley. Take it away, Chief.
Good evening, everyone. I'm Kari Haley, Assistant Fire Chief for the East Bay Regional Park District. And first, I want to thank EBMUD for inviting us to speak and talk about all the different things the Park District is doing to help prevent wildfire in the East Bay Hills. We're going to talk about two different plans that the Park District utilizes. The first plan is the Wildfire Hazard Reduction and Resource Management Plan. And the second is the Tree Dieback Mitigation Plan. Next slide, please. Our Wildfire Hazard and Resource Management Plan is really two different plans combined into one. It's the original plan that Park District utilizes to reduce hazardous fuels on Park District land. Park District currently owns 125,000 acres. So instead of trying to treat all 125,000 acres, we strategically treat different acres that are recommended treatment areas. And those areas are areas that are 200 feet within structures where they could be viable resources for the Park District, areas that are strategic routes for trails, and areas that could have eucalyptus plantations. But also, because we are a resource management agency and we legally and federally are required to protect ecological resources, we also have to have the resource management plan. And with our resource management plan, we have a goal of enhancing ecological plant features to while we're doing our work. Also, we have the goal of preserving the aesthetic landscape of our land for recreation use. So fuels management for us is really a combination of reducing fuels for fire hazard, but also enhancing forest health and the aesthetics of the park. Next slide, please. This is a picture of the East Bay Hills in 1899. And as you look here on this picture, the East Bay Hills was rolling grassland. You had some areas of shrub and tidy brush, oak, but it was completely different landscape in 1899. Next slide, please. And here's a picture of the East Bay Hills 123 years later. Even though it's the exact same plot of land, the landscape looks completely different after having trees that are now mature and also areas that have been filled in with brush. Even though these areas are the same, if they were to catch on fire, they would burn drastically different. Next slide, please. Here's a picture of Sibley Regional Preserve. And this park here in the 1900s, again, rolling grassland. As you can see, there's brush and oak, but mostly grassland. And if we look at a picture of this same hillside today, next slide, please. This is the exact same hill in 2022. It's almost completely covered with brush. The trees are more mature, and if a fire was to occur, it's going to burn drastically different after 122 years of growth. And this is part of what we're dealing with here, trying to manage the Park District land, but also I know it's interesting to see as people see that we are thinning the trees so that it's better for the forest health and for fuels reduction. I think it's important to see what the landscapes look like originally compared to what it looks like today. Next slide, please. So our fuels plan gives us recommended treatment areas. And like I was saying earlier, instead of trying to treat all 125,000 acres, which would not be fiscally even sustainable, we have targeted areas that we call recommended treatment areas. These recommended treatment areas are areas that we have CEQA clearance to do work, and they've been strategically picked. And most of those areas are 200 feet within residents, so our neighbors' homes. They could be strategic routes of the Park District. It could be infrastructure of the Park District, or like I said earlier, plantation of eucalyptus trees that are a high hazard. There's 130 of these recommended treatment areas, and it covers 3,000 acres, and it spans 9 regional parks from Sobrani Ridge and Miller Knox all the way out to Lake Chabot. Next slide, please. And how we're accomplishing all of this work is through our fire department. For those who don't know, the Park District has a fire department. We have lots of fire equipment. We have 4 Type 3s, which are the bigger, larger fire apparatus. We have 8 Type 6s, which are the smaller ones. We have 2 helicopters. We have water tenders. We have rescue gators. And even though the Park District is covered by municipal jurisdictions, the Park District's fire department is able to enhance our park users' experience, either through fire suppression or medical services or rescue duties that we can perform. But we also have a fuels management department. And our fuels management department has grown 240% in the last 5 years. The Park District has done an extensive investment on our fuel side, the prevention side of the fire department. And so now it comprises of myself as the assistant fire chief, but we also have 2 fire captains, one that supervises our 14-member fuels reduction crew, where they're able to go out and not just reduce fuels, but they're also able to fight fire when fires do occur. And then we have another captain who supervises 4 fuels reduction coordinators. Those coordinators write contracts that reduce hazardous fuels on Park District land. On average, each fuels reduction coordinator is writing contracts for about $1.2 million of fuels work, for a total of $4.6 million combined just through those 4 fuels reduction coordinators. Our fuels crew costs the district about $1.2 million annually to maintain, and these members are full-time Park District employees. Next slide. And the Park District also has a goat grazing program. We have one of the largest goat grazing programs in the East Bay. We are utilizing not one, but 4 of the larger goat grazing companies to graze our land. It encompasses 837 acres. It's spanning through 11 different parks, and it's covering 52 various sites within those parks. Most of these areas that we're grazing are within 200 feet of homes. If you happen to be one of our neighbors, you might have even seen our goats grazing, but they're very efficient and they're allowing us to keep fuels low on 837 acres of land, which would be much more expensive and harder to accomplish by utilizing people to do the same type of work. That program costs us annually about $500,000 a year. Next slide, please. Park District also utilizes prescribed fire to help reduce hazardous fuels, but also to enhance ecological features. Prescribed fire is good for enhancement of native grasses and other native plant species, but also it's good for eradicating non-native plant species. It's also a great tool for managing and reducing hazardous fuels in an economical way. One of the ways that we utilize prescribed fire, for example, in areas where we're doing fuels work deep interior into our parkland, sometimes it's hard for us to get chippers and other heavy equipment in these areas. Through our fuels crew, we're able to have them remove these hazardous fuels, create piles, and then during wintertime, we come back and we burn those piles to get rid of those hazardous fuels. But it also has, like I said earlier, ecological benefits to our parkland. And it's just one additional tool that the Park District utilizes to reduce hazardous fuels on its land. Next slide, please. And here's a picture of Miller Knox Regional Park. We've been out there all year long, and we're actually had finished the areas that are our recommended treatment areas. Now we're going after bonus acres where we filed a notice of exemption, and we're doing additional areas so that we can really get that area buttoned up while we're there. They had lots of dead standing trees that were in the area, as you can see here on the left. And it was really a combination of all 3 methods that we utilize. So our fuels reduction coordinator wrote tree contracts to thin these dead, dying trees. Our 15-person hand crew went out and reduced the brush that you can see on the hillside. And then after those 2 resources did their work, we had our goats come in and graze the area. And on the right is the outcome of all 3 of those methods and the work that we did out there for the community of Richmond. Next slide, please. And here is a project that we did along with EBMUD, our close partners, the Grizzly Peak Strategic Ridgeline Fuel Break. And we were able to work with EBMUD and UC Berkeley. And up in Grizzly Peak, I'm not sure if you've been there, but especially during COVID, the area changed drastically with just more activity and higher fire risk. And so normally, instead of doing a fuels project and not talking to your partners and then ending up with a mosaic of patchwork where work was done on your property, but not your neighboring agency, we're able to work together, coordinate, tie in our fuel break so that it was continuous between EBMUD and UC Berkeley and East Bay Regional Park District. It's just an example of the type of work we do working with our close partners. Next slide, please. And we're going to get into our tree dieback mitigation plan. And what that's about is that the Park District has truly been affected by climate change. And we have dead, dying, and declining trees that are on our land. We've targeted about 1,200 acres. And so we were able to come up with a plan to mitigate the hazards that are now there. And let me go ahead into the next slide. So how we came about doing that is that we first analyzed the highest hazards on our parkland. We utilized our helicopter to figure out what areas had the largest amounts of dead standing trees. We also had foresters and fuels direction coordinators go out and do ground truthing. And from there, we were able to get a count of acreage of dead standing trees. But then we went ahead and took census data of the cities and the population and a number of residents in these households to find out the population that affected. And then we also used another data point, which was the number of wildland fires that were occurring on our land, so we could determine the highest risk areas that we could first start with. And then once we had those parks allocated, which was Anthony Chabot, Redwood, Tilden, and Miller Knox, we were able to come up with a budget to figure out how much this was going to cost. Of course, that was in the millions. And then we were able to start to seek funding so that we could actually execute this plan. Next slide. So what you're looking at is a picture of the East Bay Hills in the 1890s. And unfortunately, some of the earlier settlers planted plantations of eucalyptus, and they thought at the time they were going to be able to use it for lumber. And it was a failed venture. And so now, many years later, the Park District purchased this land, and we've turned it into our parks. And one of the parks is Anthony Chabot in Oakland. Next slide, please. So here's Anthony Chabot today, and we now have 580 acres of dead standing trees, or declining. And we're mostly eucalyptus that were plantation planted in the late 1800s. And so we were able to now start reducing these hazardous trees on this Park District land. And we were able to find out by thinning these trees, not only will we be able to reduce the fire hazard, but the trees that remain will be healthier because they will have more resources to absorb water, sunlight, and have opportunity to stop the decline. We are starting with 80 acres. 80 acres is the largest fuels project at one time that we have done as an agency. So that just tells you the scale that's changed because of climate change. And this project actually began last week. Next slide, please. And part of this project, we call it the Anthony Chabot Pilot Project. The reason we call it a pilot project is because we are utilizing an innovative piece of equipment called the carbonator. The Park District is committed to making sure that our actions don't contribute to climate change, which is exactly what's affecting our trees. So we wanted to try to figure out ways of doing work differently so we could reduce our carbon footprint. And so by using the carbonator and being able to process biomass, and biomass is trees, matter of trees, brush, etc. We're able to incinerate the biomass into the carbonator, and it's going to produce a product called biochar. This is the first project in the East Bay that the government agency has done using the carbonator. So very excited. We're hoping for good results, but we know that we'll be able to reduce the truck traffic by 10 times. We'll be able to reduce the carbon emissions by 10 times. Normally, we would be trucking these trees to cogen facilities in Sacramento instead of processing on site. We're also going to use that biochar on Park District land. Biochar has different benefits. It sequesters carbon. This project should be able to sequester 8,000 tons of carbon. It also enhances soil structures, which is a benefit for drought-stressed land. It has water retention features. And so all these things are a benefit. And so we're hoping that this might be a new way of processing biomass while doing fuels work. Next slide. And lastly, why do we do this type of work? Why do we invest millions of dollars annually in reducing hazardous fuels? Well, we are convinced that doing fuels management along with a quick fire suppression from our local agencies is the combination to protecting our neighbors from catastrophic wildfire. And so for us, it's been a proven method. The pictures that you're seeing here on the slide is from a fire that happened earlier this year. It was in the Oakland Hills. It was on a red flag day. That is not an ideal day to have any fire. And so all the conditions were lined up for bad things to happen. But because we had been doing fuels management work, reducing fuels in a fuel break, thinning trees, having our fuel crew go in and do work, having our goats go in and graze, along with the quick fire suppression from Oakland Fire and Regional Parks Fire, we're able to keep this fire extremely small. As you can see those neighbors across the street, and we're able to prevent them from the effects of catastrophic wildfire. That's the end of my presentation. I'd be more than happy to take any questions.
Thank you very much, Chief. That was actually a lot of good information. I'm going to be posing some questions to you. I'm going to turn off the presentation for now so I can read some of these questions to you. If you can hang with us for a little bit when we go over maybe 5 or 10 minutes to get some of these questions answered, if you can bear with us. Some of the questions that I have here, and I'm going to ask this question first of you, Chief Haley, and then if Scott, if you can chime in. Are you doing anything to bring back native grasses on the grasslands in the parks or in the EBMUD watershed? So we'll start first with the chief.
Yeah, for us, so we have a stewardship department, and all the work that we do in the fire department is hand in hand with our stewardship department. It's an extremely large department with biologists that go out and give us fuels prescriptions that we adhere to. The work that we do when we do thinning work, it's a delicate balance because we don't want to open up the canopy too much that it causes the landscape to change and have brush take over. And so we're always, when we're thinning these areas, we're making sure that we still have shaded fuel breaks. And the work that we do to enhance native grasses is the prescribed fire activities. And so our stewardship department will give us areas that either there's an invasive species like the Medusa head or a certain type of grass that they want to enhance. And then based off weather and different permitting, we try to conduct prescribed fire to benefit those different projects.
Right. Do you have anything to add, Scott, on that question?
I would just add that we do try to enhance the native grasslands on the watershed, and we address that through our grazing program and through the annual grazing plans that are developed each year for each allotment. You know, we build in management directives in those plans to enhance the native grasslands throughout the East Bay watershed.
Okay. This question, I think, is for Chief Haley. Is the 1899 photo, is that showcasing grasslands because it was logged out?
Because it was what?
The 1899 photo is showing grasslands because it was logged out, meaning the trees, all the trees were cut in that the time for the photo.
No, that was just to show what the land looked like in the late 1800s.
Oh, okay.
And so, and in comparison to what the same land looks like today in 2022.
Oh, okay. This question is for both of you. We'll start with Scott this time. What are you going to replace the Monterey pines with? Hopefully native, such as coast or live oak, or coast live oak, sorry.
Yes.
Go ahead, Scott.
Okay, thanks, Kari. The pines forest will be replaced by the native live oak that are growing in the area already. That process is well underway.
Okay. You have anything to add, Chief?
Yeah, we use the same technique. So when we are doing our fuels prescriptions, we are making sure that we leave the sprouts of oaks and bays, the native plants that are trees that are there. And that's really going to be the new forested areas, 20 years from now. And so you can look in an area that's been thinned and you'll see young tree sprouts, and that's the next forest, but it's just going to take time for those trees to grow.
Okay. Here's another question. What was the fire return interval for this region prior to the ecosystem disruption by suppression-centric modalities?
Can you repeat that question for me?
Yeah, it was this is what was the fire return interval for this region prior to the ecosystem disruption by suppression-centric modalities?
I'm not sure if I completely understand the question, but I'm not sure if I quite understand that question.
Okay,
You can
yeah,
take I'll take a stab at it. I would say it was almost annually, you know, when the Native Americans were on the land, it was annually. And it was very, very low intensity fire. As Chief Haley pointed out, the landscape was dominated by grassland. There were oaks in the riparian, you know, in the canyons and whatnot. But I mean, fire went through that area, some portion of that area every year. And then when grazing was introduced to the Bay Area, that's when it all kind of started to change. They wanted to retain the grassland for forage for livestock. They didn't necessarily want to burn it off every year. There was a significant change in the way it was managed, and that brought us up to kind of where we are now.
Yeah, okay, thank you. I have, I think this will be the last questions, but we have one really long question that I'd like to see if you guys get some input. So bear with me, this is actually a long comment / question. Managing fuel is one limited goal for the use of fires in the landscapes. However, California ecosystems have evolved with fire and many native plants, animals, and ecosystems that benefit from frequent low-intensity burns. In fact, some native plants only germinate after a fire, and low-intensity burns increase biodiversity by decreasing patchiness in the landscape. But in order to get these benefits, you need to acknowledge the plant phenology and the need those goals in mind before doing a burn. Let me just cut to the question. What are you doing to get indigenous access to these primordial lands for use of plants for medicines, packaging, and also parts of the many lands that are in the East Mamaw service area? I guess it's just, you know, how are you basically bringing back some of the natives to these lands and try to stop invasive species from being in our watersheds?
That's a
yeah.
Well, you want that's a lot of there's a lot there, and I'm not sure I got it all, but you know, I agree with what was said there, but I'm not sure I got all the questions right. But in terms of the pyrophytes that, you know, are fire dependent plant species, we have those, and Regional Park does as well. And some of those are senescent or in decline, and we've done work in the past to try and bring them back. Some successfully, some unsuccessfully, and that's one of the big challenges. Prescribed fire is a great tool. All land managers love it. Recognize how integral it is to really successful resource management. But to turn back the clock and use it in the way that it's most effective is just that's the huge challenge, because there's houses all around these watersheds now, throughout the watersheds. There is, you know, terrible air quality many days out of the year. There are a lot of other things that inhibit the effective use of prescribed fire and all the benefits that land managers recognize could come with it. It's a big, big challenge. And that applies to, you know, applying fire to these fire dependent resources. And we are trying, and we've tried in certain areas. We have a certain species on our watershed, knobcone pine. It only germinates with fire. It takes fire to open those cones. We have one of the last knobcone pine forests in the East Bay on our property. We've gone up there, we've put fire on the ground. And it's in a really dicey area for using fire as well. It's a challenge. But anyway, we've tried to put fire on the ground and get cones to germinate kind of artificially, rather than a broadcast burn going through the area. But anyway, we are working with things like that. We try to always, when developing a prescription for prescribed fire, I mean, we're always taking into consideration what is the effect. It's not just to remove the vegetation from the landscape. What are the effects? The biological, ecological effects of fire. We want them to be beneficial. We want them to be desirable. Like the chief mentioned, type conversion. We also use fire in rangeland conditions for weed eradication, as well as fuel management for fuel reduction, pile burning, and broadcast burning. But anyway, those are all really good questions. One thing we haven't done a lot in the Bay Area is I don't think we've really had any real strong outreach. I know we haven't, to Native Americans and bringing them into the loop in terms of prescribed fire. But that's a great suggestion.
Okay.
It is. And the only thing I would add is through our stewardship department, we were able to get some outreach with Native American groups who were interested in doing prescribed fire in conjunction with us. And also, even though we believe it's a great tool, it politically has its challenges depending on what areas that you use prescribed fire. If you're using prescribed fire in our parks that are in the Oakland or Berkeley Hills, our neighbors there, are still traumatized from the effects of the 1991 Hills fire. And so even though fire has its benefits to reducing hazardous fuels, for some, the smell of smoke is traumatizing. And so we've come into those challenges of the balance of wanting to be able to do prescribed fire, but at the same time, understanding that the community may still be traumatized, and it might just be too soon for us to be doing these type of activities.
Okay. Because we are gone over 10 minutes over the hour, we can end it here. I would like to thank both Scott Hill and Chief Hele for their generous time. And I would also like to thank everyone who came. I know we didn't get to all of your questions and answers, but we will do our best to answer these questions. If you have any questions that you can think of you want to send us, you can do it at community@eastbaymud.com. You can send us your questions, and we will do our best to answer them rather quickly. But I'd like to thank everyone for their time in coming and hearing both speakers. I certainly enjoyed it and learned a lot. And don't forget that we will have another Water Wednesdays next October. It happens every 3rd of the month. Next one is going to be on demystifying desalination. And it's going to be October 19th. Make sure you, when the notice go out, that you sign up. It's going to be a very great presentation. I myself can't wait to hear it because it's very interested in that topic. So I'd like to thank everyone for coming tonight, and have a good evening. Thank you very much. Bye, everyone.
Thank you.
Thank you. Bye-bye.